Today we are going to discuss about work. What is work? Work is defined as the rate of change of work. Not work, but we are going to discuss about power. Power is what? Power is defined as the rate of change of work or rate of change of energy, and that is basically power. Power is having its formula as rate of change of work, which means it is work done per unit time. It is work done per unit time or rate of change of work, rate of change of energy, and power is basically a scalar quantity. We are going to further discuss why is it a scalar quantity when we are going to further derive it. So what is the formula for power? It is what works formula is joule time second. So its formula is joule per second is equals to watt, is equals to watt, and power is having its value, um, which means 1 watt is equals to 1 joule per 1 second. And we can say that when it comes to the MK system, uh, 1 joule is equals to kilogram meter square per second square, and when we are going to multiply it, the answer will be 1 kilogram meter square per second cube. So accordingly, the unit for power is kilogram meter square per second cube, due to which its dimension will be m power 1 l power square e power minus 3. Accordingly, if we have power and this is power, and we know that the power is work is having its formula as Fs, F dot D, F dot D. Let me just write it, F dot D upon time. Now, as we know that displacement upon time is equals to velocity, so it will ultimately become F dot V. Due to which we can also say that power is the dot product of force and velocity, due to which we also consider power as a scalar quantity. Why is it scalar quantity? Because it is a dot product of force and velocity. After which, if we are having other conditions as well, that if uh, work is increased, power is increased. If time is increased, power is decreased. Now there are some other conditions which we call as the average power. What is average power? Average power is the power which is obtained by total work upon total time. Total work upon total time is equals to average power. Secondly, there is instantaneous power. Instantaneous power, which is such a manner that it is total work divided by delta divided by time divided by time nearest to zero, which means time at its shortest interval. Total work upon time at its shortest interval is known as the instantaneous power. And whenever the instantaneous power is equals to the average power, then the power will be uniform. If instantaneous power is not equal to average power, then the power will be non-uniform. Accordingly, uh, if work time is equals to 0, whenever we are calculating instantaneous power, we never take the value of time as 0, because if we are having the value of time as 0, then power is equals to work upon time, which is 0, which will lead to a condition known as infinity power, which will be infinity power. Infinity power, what does that means? That means that power will be equal to infinity, which means that here power is infinity, which means this is a condition in which there is infinite power, limitless power, and this condition doesn't exist. Because if you are doing work, there's definitely certain amount of time which is being consumed. So if there's no time consumed, and even if you are doing work, then that is not possible condition, infinite condition. This is why we don't take the value of instantaneous power t as 0, because it can lead to it can lead to infinity power. After which we are having certain units of power as well, such as In LCGS system, what is the unit of power? CGS system, we are having the unit of power is erg per second. In FPS system, the unit of power is horsepower. 1 horsepower is equal to 746 watt, 746 watt, and 1 watt is equals to 0.0013 horsepower. Accordingly, when it comes to the unit of power, we can also calculate power in terms of electricity, as power is equals to IV. Power is equals to IV in terms of electricity. In terms of electrical power, power is equals to IV. We can also say that power is equals to I square R, where R is a resistance. Apart from this, power is having power is having its value as, so here um, I guess everything is discussed or something else is left. Nothing else is left, so we are going to discuss about energy. So as we know that power is having the following units, but energy is also having several units such as kilowatt hour, as well as uh, joule, erg, calorie, as well as there is EV, electron volt, BTU, the unit of energy, as well as apart from this joule, erg, calorie, EV, BTU, there is another unit which is known as, which is its actual unit, Newton meter. Basically we don't write it here because 1 joule is equals to 1 Newton into 1 meter. So 1 joule is equals to 1 Newton into 1 meter, which we have previously described. 1 Newton into 1 meter. Kilowatt hour is equals to how many joules? It is equals to 3.6 megajoules, 3.6 joules, 3.6 into 10 is power 6 joules, which is equals to 3.6 megajoules. Now, erg, 1 erg is equals to how many joules? It is equals to 10 is power minus 7 joules. 1 calorie is equals to 4.18 joules. 1 electron volt is equals to 1.6 into 10 is power minus 19 joules. 1 BTU is equals to 1055 or 1052 joules. So, mostly we consider the unit of kilowatt hour as unit of energy, as a commercial unit of electrical energy whenever we are calculating electrical energy. 1 joule, 1 joule is a SI unit of energy. Erg is a unit of energy in SI system. Calorie and BTU are the units which we utilize in calculating thermodynamics. Electron volt is the smallest unit of electrical, is the smallest unit of energy which is used at atomic level. Kilowatt is the largest unit of energy. Apart from this, there is another unit which we call as watt second, derived from the formula, derived from the formula of power. It is watt second. And these are all of this is all about this video, and hopefully you enjoyed it.